Okay, so we're going to begin Unit 3 with Lesson 1, and Unit 3 is all about triangles. And so what we're going to learn today is how can we determine if two triangles are congruent. And remember, congruent means the same. So there are several different scenarios or postulates that will tell us if triangles are congruent. So here we have two triangles. Notice that we have some markings on the two triangles. And remember, this mark on this triangle corresponds to this mark on this triangle, and what that tells us is that these two marks, or these two sides of the triangles, are congruent. And notice that that's the case for all three sides. This side is congruent to a side of this triangle. The side with the two little tick marks is congruent to this side of the second triangle, and BC is congruent to MK. So, so here we have, and I'm going to kind of highlight this a little bit. So AB is congruent to LM, and let's see, AC, oops, excuse me, AC is congruent to LK, and then BC is congruent to MK. So when you know three pairs of corresponding sides are congruent, then you know that these two triangles are congruent. They are the same. And if we were to take this triangle right here and kind of rotate it and flip it, we could put this triangle directly on top of this one. So, how can we talk about that very briefly? And it says, what do you suppose SSS stands for? That means side, side, side. So when you have three pairs, of corresponding sides that are congruent, the two triangles are congruent. Let's talk about how we could write the congruency. Let's name these two triangles. So there's three different ways you could name this particular triangle. I like ABC, and ABC is congruent to this triangle. Now it's very important how we write the angle of these triangles, or how we name this triangle. Notice that here I started with A and I went to B. So I have to do the same thing with L, or the LMK angle or triangle. And so here I started with AB, then I go from LK, not LK, but LM. So I have to name this LMK. So LMK. So triangle ABC is congruent to triangle LMK. So another way that you can make sure that you have named and labeled or set up this congruency correctly is ask yourself this: AB is congruent to LM. Is that true? And it is. How about BC? BC is congruent to MK. And then AC is congruent to LK. So you can always check yourself to make sure that you've written the triangle correctly or named it correctly. So whenever you have three pairs of corresponding sides that are congruent, you know your two triangles are congruent. All right, then let's look at another scenario. when we look at this, these two triangles, notice that this side of this triangle is congruent to this side, and we know that because of the markings. We also know that this side is congruent to this side. Now, in this case, we have two pairs of sides that are congruent. So now what we focus on, look at what else we know, and that's pretty dry right there. So let me see if I have something else. Here we go. So notice that we have this angle labeled and this angle labeled. So what we have here is we have one pair of sides that are congruent. We have another pair of sides that are congruent. We also have an angle that is congruent, a pair of angles. So when we have two pairs of corresponding sides, two pairs, that's key right there, two pairs of corresponding sides and their included angle. Okay, what do we mean by included? Included means that the angle is in between the two legs or the two sides. The angle is included within the sides. So it says two pairs of corresponding sides and their included angle are congruent. So, excuse me, we have a side, we have our angle, and we have another side that is congruent to side, angle, side. So SAS stands for side, angle, side. So when we know two pairs of corresponding angles and their included angle are congruent, we know that we have side, angle, side, and therefore the two triangles are congruent. Okay, so let's name the congruent C. So I have triangle, I still like, let's do ACB. Triangle ACB is congruent to FED. Again, AC is congruent to FE, and then CB is congruent to ED, and so on. So, two pairs of corresponding sides and their included angle, the two triangles are congruent or the same. If we were to take this triangle and flip it and slide it over, this triangle would lie directly on top of this triangle. Okay? Okay. Pardon me. So those two scenarios have more sides included than angles. Okay, but now let's look at the next two scenarios of how we can determine if two triangles are congruent or the same. That is when perhaps you have two pairs of corresponding angles and their included side are congruent. So let's take a look at what we have. So notice that we have angle B is congruent to angle Y here. We have the side AB and the side XY that are congruent because they have the little markings. And then we have this angle A and angle X that are congruent also. Now let's look at the relationship between the angles and the side. Notice that you have two angles and you have a side between them. You have your two angles and your side between them. This is when you have two corresponding angles and their included side. The side in between the two angles are congruent. So we would refer to this as angle, side, angle. So how would we name these triangles and show the congruent statement? That would be triangle ABC is congruent to X, Y, Z. And you can see where AB is congruent to XY, yes. BC would be congruent to YZ, this piece, and AC and XZ would be congruent as well. If I were to take this triangle and slide it around and turn it, I could lay this triangle on top of this triangle. And therefore, they are congruent. And they are congruent because of the angle, side, angle postulate. Angle, side, angle. All right, now let's move on and look at two pairs of corresponding angles and their non-included side. If you know two pairs of corresponding angles and their non-included sides are congruent, then you know the two triangles are congruent. Okay, so let's take a look at what we've got. I noticed that I have an angle K is congruent with angle U. I also know that I have angle M congruent to angle S. And I also know that I have this side that is adjacent to, or it's the non-included side, but it is opposite the yellow angle. I know that KL is congruent to TU. So notice that this side is not included between S and U, and LK is not included between K and M. So when you have two pairs of corresponding angles and their non-included side, when you know that they are congruent, you know then the two triangles are congruent. So if I were to take, let's say, this triangle and flip this triangle over, and then I could slide it on top of this one. And so what is this giving us? We have angle, angle, side. We have angle, angle, side. So angle, angle, side, if we know that two pairs of corresponding angles are congruent and their non-included side are congruent, then we know that these two triangles are congruent by angle, angle, side. Now, how could we name our triangles? We could name our triangles MKL is congruent to SUT. Okay, so you have to name them in the same order. I started this one with M and I went to K and then I went to L. So I went from yellow angle to pink angle, yellow angle to pink angle to the included or the corresponding side. Okay, so those are 4 scenarios. We've got a couple more. So a couple more we're going to look at is, let's take a look at right triangles. So a right triangle, we really treat this no differently than the others. The only difference is that in these 2 scenarios, we have a right angle, which means the triangles are right triangles. So if you have right triangles and the hypotenuse and one pair of corresponding acute angles are congruent, then you know the 2 triangles are congruent. So what does that look like? Okay, hypotenuse. The hypotenuse of this triangle is congruent to the hypotenuse of this triangle. So we've got that, the hypotenuse. Now let's talk about the pair of corresponding acute angles. So here we have this angle at Q. We have this angle at B, and they are corresponding and they are congruent. So, why is it that that's the only thing that's necessary? Well, if you really think about this angle right here, these two angles are congruent. So really, we have angle, angle, side, angle, angle, side. And therefore, by angle, angle, side, we know that these two triangles are congruent. Angle, angle, side. How do we name this? We could say that triangle RQP is congruent to BAC. Okay? All right, a few more little things. All right, so the last postulate that we're going to be talking about, or relationship, is this. If you know that the hypotenuse of one triangle is congruent to the hypotenuse of the other, and you have a pair of legs or sides that are congruent, then you know by the hypotenuse leg postulate that these two triangles, excuse me, are congruent. So, hypotenuse leg postulate describes the congruency, or the reason why we know that the two triangles are congruent. Okay, so now we have another thing to just re-emphasize is that if you have two triangles that are congruent, then the corresponding parts are of congruent triangles are congruent. So what does that mean? That means that, and this really should have a line over it, AB, side AB is congruent to, well, I don't have to look at the picture. All I have to do is look at this right here. So side AB is congruent to side XY. Side BC, this one right here, is congruent to YZ. Side AC will be congruent to side XZ. That's why early on, writing this congruent statement is very important, how you write them. Okay, and then finishing this out, angle A would be congruent to angle X, angle B congruent to angle Y, and angle C will be congruent to angle Z. Okay, so corresponding parts of congruent triangles are congruent. All right, the last thing we'll do is I want us to take a look at two triangles, and I want us to describe the postulate that proves that the given triangles are congruent, and then I want us to state the triangle congruence, make this triangle congruent statement. All right, so let's take a look. All right, so here we have two triangles, and those two triangles have a leg or two sides that are congruent. Now, they also have two angles that are congruent, but where's the third side? There's got to be something else that is congruent. Well, notice that these two triangles are connected. They have or share a side. Well, if they share a side, that means that this side would be a congruent would be congruent to both. So these two are congruent. FIG, F FIG is congruent to HIG, triangle HIG. Now, what postulate proves that these two are? Well, what did we use? We had a side, we had another side, and we had the angle between them. So this would be side, angle, side. So these two triangles are congruent. Triangle FIG and triangle HIG are congruent because of the side, angle, side postulate, because they have side, angle, and sides that are congruent. All right, we have another figure. Triangle NOP. So we have this triangle right here. I'm going to draw on it. NOP. I'll even draw this here. There's triangle NOP. In this triangle, we see that this leg is congruent to this leg. We have this leg, OP, that is congruent to this leg. And since they share a side, then this is going to be congruent as well. So the three pieces of information that are congruent are all three sides. So this postulate would be the side, side, side postulate. So we know that these two triangles are congruent based on the side, side, side postulate. Okay, so now we need to name what triangle NOP is congruent to. So that would be, so NOP would have to be congruent to NQP. Okay. All right, then on our next one, let's talk about what we're given. We know that this leg right here, we have this triangle, and we have this triangle. Okay, looks like a bow tie. We know that this side and this side, these two are congruent. We also know that we have this angle being congruent to this angle. But we don't have any other information that's highlighted or given to us. But I think if we look, we might be able to determine some information that's not necessarily given to us. What kind of angles are these two angles here? These two angles are vertical angles, and vertical angles are always congruent. So how do we state the congruent statement, or what postulate? I have angle, I have a side, I have an angle. Angle, side, angle. So I know that these two triangles are congruent based on the side, angle, side postulate. And how do I write the congruent statement? Triangle ABC is congruent to, okay, I have to start this triangle with the D, and then E, and then I think that's C. So triangle DEC. So the way that you write your angles, the naming of your angles, is extremely important. All right, I'm going to do a couple more, and then, sorry about that. What's happening here? There we go. So I'm going to do a couple more, and then you'll have, be good to go on your assignment. Okay, so here we have another triangle, or two triangles that share a side. That's the side that they share. And notice that this angle and this angle are congruent. And let's see if I have another one. Nope, not there. And these two angles here are congruent. Okay, so let's talk about what we have. We have this angle we have this side, we have angle, the included side. So this would be angle, no, sorry, this would be, yes, angle, side, angle. And a congruent statement could be triangle SUR is congruent to SUT. Okay? And then finally, here we have two triangles. Again, this is a shared side. So we have an angle, and we have a side. Angle, angle, side. So this is going to be, these two triangles are congruent based on the angle, not a triangle, angle, side postulate. And a congruent statement would be that triangle, let's say KJM is congruent to KLM. And so those are the different scenarios that we can use or follow to determine if two triangles are congruent. You have angle, side, angle, 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 side. You've got, let me pull this back in. If you have three pairs of corresponding sides congruent, then the two triangles are congruent, and so on. So these are the different ways that you can determine, these are the different ways that we can determine if two triangles are congruent.